Have you ever wondered how doctors can get a look inside our bodies to figure out what's going on? One of the most amazing ways is with an MRI. We're talking about incredibly detailed pictures made using powerful magnets and, get this, with absolutely no harmful radiation. So, how does this incredible technology actually work? Well, let's dive in. All right, here's our game plan for this explainer. First, we'll look at what makes an MRI so special. Then, we'll break down how these amazing machines work. We'll meet the people who invented them, cover some really important safety rules, and finally, we'll take a look at what the future holds for this technology. So, the first big challenge for doctors was always seeing the soft parts of the body. Things like the brain, muscles, and organs. X-rays aren't really built for that. They needed a new way to see inside safely and clearly, and that's exactly where the MRI came in. So, how does an MRI stack up against other imaging tools? Well, the first big thing is right there, zero radiation. Unlike CT scans or X-rays, that's huge. But even more important, it gives superior detail for soft tissue. This means it's pretty much the best tool doctors have for getting a crystal clear look at the brain, muscles, and all those internal organs. Okay, so how does it actually do that? This is where it gets really cool. MRI machines basically create pictures by using giant magnets to, well, sort of talk to the water that's already inside of us. Our bodies are mostly water, right? And inside every single water molecule, there are hydrogen atoms. Each of those has a proton, and you can think of each proton as a tiny microscopic magnet. Normally, all of these little magnets are just spinning around, pointing in every which way, totally random. But when you slide into an MRI scanner, you're entering an incredibly powerful magnetic field. It is so strong, up to 60,000 times stronger than the Earth's magnetic field, that it makes all those tiny proton magnets in your body snap to attention and line up, all pointing in the same direction. The whole thing really comes down to 4 simple steps. First, the big magnet aligns all the protons. Second, the machine sends in a harmless radio wave, which gives the protons a little kick of energy and knocks them out of line. Third, when that radio wave turns off, the protons relax back into place, and as they do, they release a tiny signal. And finally, a powerful computer listens to all those signals and uses them to build a really detailed image. Now, here's the real magic. The computer can listen to these signals in different ways to create different kinds of pictures. T1 images are like an anatomy scan. They show the body's structure really well. But T2 images are the problem finders. They're designed so that any area with extra water, like swelling from an injury, glows bright white, making it super easy for doctors to spot. So who came up with this incredible technology? Well, the story of the scientists who created MRI is a pretty wild ride. It's full of brilliant ideas, competition, and yeah, even a big argument over who really deserved the credit. The MRI wasn't just invented by one person in a lab. The journey started way back in the 40s with the basic science. Then, in 1971, Dr. Damadeyan made a critical discovery. Cancerous tissue sends out a different signal than healthy tissue. A couple of years later, Dr. Lederber figured out how to turn those signals into a two-dimensional picture. And finally, Sir Mansfield came along and made the whole process much faster, fast enough for it to be practical in hospitals. This whole history led to a major controversy. In 2003, the Nobel Prize was given to Lauterbur and Mansfield, but Dr. Damadeyan was left out. His supporters were absolutely outraged. They believed his discovery of the medical use was the most important step of all. They even took out full-page ads in newspapers with this headline to protest the decision. That incredibly powerful magnet we've been talking about isn't just for making images. It also means that an MRI is a very delicate tool, and that's why there are extremely strict safety rules. Let's take a look at why safety is so critical. Okay, this is the single most important thing to know about MRI safety. That giant magnet? It's never turned off, ever. It is on 24 hours a day, 7 days a week. And that constant magnetic pull creates some very specific dangers. So these dangers all come from that always-on magnet. Any metal object, from a pair of scissors to a wheelchair, can get pulled into the machine at super high speeds, turning it into a dangerous projectile. The magnet can also be risky for people with certain older medical implants. On top of that, the machine is extremely loud, so hearing protection is a must. And finally, there's a very rare emergency called a quench. A quench happens if the magnet starts to fail. The whole system is cooled by super cold liquid helium, and if something goes wrong, that helium can instantly boil and turn into a massive cloud of gas. That gas has to escape safely through a special pipe on the roof. If it doesn't, it can fill the room in seconds, pushing out all the oxygen. So to wrap things up, let's look at where this amazing technology is headed. The future of MRI is kind of interesting because it's going in two opposite directions at the same time. It's getting much bigger, and it's also getting much smaller. On one side, you have these gigantic, ultra-powerful machines like Isolt over in France. It's so strong it can see tiny details in the brain that might help us detect diseases years earlier than we can now. But on the other side, you've got small, portable scanners like the Swoop. This little machine can be wheeled right to a patient's bedside, bringing this life-saving tech to people who are too sick to be moved. So, from a simple physics experiment to a tool that can actually map the human brain, MRI has completely transformed medicine. It allows us to see inside ourselves in a way nobody ever thought was possible. And it leaves us with a really exciting question. With this incredible power, what secrets of the human body and mind will we uncover next?